Welcome to the Deep Dive. Today we're jumping into something pretty fascinating. China's development of these two sixth-generation fighter prototypes, the J36 and the J50.
Yeah, and we've got some sources here that give us a really interesting look behind the curtain, so to speak, at the design thinking, the technology.
Right, the tech. So our mission for this deep dive, really try and unpack the innovations, the strategy behind China aiming for, well, air superiority with these jets.
And it's not just what they're building, but trying to understand why this way and what it signals.
Exactly. And the first thing that jumps out is they're not just doing one. It's this parallel development, two different planes.
Mm-hmm. You've got the J36, which has this really wide delta wing, almost like the sources say a ginkgo leaf.
Yeah, I saw that. Distinctive. And then the J50, much sleeker, seems more focused on stealth maybe.
Yeah.
With that lambda wing.
Yeah.
It's quite a contrast.
It really is.
Yeah.
And developing both at once, that's interesting in itself. It's not just hedging, maybe. It could suggest they're exploring different paths, trying to figure out the absolute best approach for, the future.
Letting them iterate faster, perhaps, instead of locking into one design too early.
Could be. It potentially allows them to leapfrog others who committed earlier.
Okay, let's dig into the J36 first then. That big delta wing obviously provides a lot of lift, right?
Definitely. Good for maneuverability across different speeds. But the really clever bit seems to be on the trailing edge.
You mean those tiny microflaps? The sources mentioned dozens of them?
Yeah, exactly. Dozens of little independent surfaces. Think of them like tiny, super fast spoilers.
Instead of one big flap.
Right. They can make incredibly small, incredibly fast adjustments to the airflow. So you get this almost instant control, really precise.
Especially for tricky stuff like roll and yaw control.
Precisely. The sources mention high-speed footage showing them pulsing. That really gives you a sense of how active they are, constantly shaping those vortices.
Wow. Okay. And underneath, you've got 3 engine nozzles clustered together. Reports mention a really bright orange afterburner glow.
Yeah, 3 engines suggest a serious amount of thrust, which you need for agility. That bright glow points to powerful engines, high temperatures.
And their position hints at thrust vectoring down the line.
Almost certainly. Being able to point that thrust slightly off axis, up, down, sideways, that lets you change direction incredibly quickly, even at low speeds. Huge advantage in a dogfight.
Makes sense. And of course, stealth. Any modern fighter needs it. What are we seeing on the J36 for that?
Well, it's got several features, the serrated edges on the engine inlets, sawtooth patterns on access panels.
Standard stuff for breaking up radar reflections.
Kind of. The idea is to scatter the radar energy, not bounce it straight back. Plus, they've apparently concealed the sensor windows, which can be radar hotspots.
But it's not just about being sneaky on radar. The J36 apparently showed off some pretty impressive low-speed handling, too.
Oh, yeah. There was a demonstration where it slowed right down almost to a hover, nose high, and then it deliberately went into a flat spin.
Deliberately.
And recovered smoothly. That shows incredible control authority right at the edge of the flight envelope, speaks volumes about the aerodynamics, and, importantly, the flight control software.
Okay, so that's the J36. Let's switch gears to the J50, the ghost-like one. How's its design philosophy different?
The J50 really seems to put stealth first and foremost. You see it immediately in that pure lambda wing shape. It just blends seamlessly into the fuselage. Very clean lines.
Less sharp angles for radar to catch.
Exactly. And notably, no vertical tail fins like you see on most fighters, including the J36. That's a big step for stealth.
Right. So without those tails, how does it control yaw? How does it stay stable?
It uses broad 11s on the wing's trailing edge. They handle both pitch and roll, like elevators and ailerons combined. And then for yaw, it has these things called rudder vands out near the wingtips.
Ah, okay. Integrated controls again. All for that low observability.
Seems like it. It's all geared towards shrinking that radar cross-section.
Now, there was that interesting test mentioned mid-April where they jettisoned the PTO probe, the thing that sticks out to measure airspeed.
Yeah, the pitot tube assembly. That was bold.
Why do that mid-flight? Seems risky.
It shows incredible confidence in their internal sensors. They basically said, okay, we don't need this external probe anymore. They had to rely completely on embedded sensors, maybe these laser-inscribed airflow gauges mentioned, to get all the air data.
And the benefit is?
Better stealth. Obviously, removing something sticking out helps. But more than that, it signals that their internal integrated sensors are reliable and accurate enough to fly the plane safely. That's a big deal.
Okay. And while the J36 impressed at low speed, the J50 seems more about high-speed agility.
That's the impression, yeah. Tight loops overhead, steep dives with pullouts close to the ground.
Not just showing off, presumably.
No, that's about stress testing the digital flight control laws. Pushing the system, making sure it's stable and responsive right at the top end of its speed range.
So both planes rely heavily on these advanced digital flight controls. It sounds like more than just fly-by-wire.
Oh, absolutely. We're talking incredibly sophisticated systems. They're constantly crunching data from loads of sensors, inertial units, pressure sensors, accelerometers.
Feeding it all into multiple computers.
Multiple redundant processors, yeah. Hundreds of times a second. Making tiny adjustments to the control surfaces almost before the pilot even thinks about it.
Yeah.
It gives amazing stability and responsiveness.
Which leads to that description, pilots apparently use a telepathic feel.
Right. It sounds like hyperbole, but it points to this incredibly seamless connection between the pilot's intent and the aircraft's response.
So the plane just does what you want it to do, almost intuitively.
Sort of. It frees up the pilot's brain power, Less focus on the mechanics of flying, more on the actual tactics, making decisions. In a high-stress fight, that could be a massive edge. The plane becomes an extension of your will.
Got it. Now, thrust vectoring. Both are getting it, but implemented differently.
That's the plan, yeah. For the J36, it looks like retrofit shrouds or vanes inside the existing nozzle setup. Still gives you that ability to vector thrust for super maneuverability.
Okay. And the J50.
For the J50, it sounds like the nozzles will be embedded more directly into the fuselage itself, a more integrated design.
Which probably helps with stealth too, right? A smoother profile.
You'd think so. Less drag, potentially a smaller radar signature compared to external actuators. It fits that overall stealth focus of the J50.
Beyond just flying, the stealth tech itself. We touched on shapes, but what about materials and sensors?
Both seem to use things like diverterless supersonic inlets, DSI bumps instead of complex ramps. Helps manage airflow into the engine at high speed while reducing radar reflections from the engine face.
And RAM coatings, radar-absorbent materials.
Oh, yeah. Extensive use of RAM is mentioned. Plus those serrated panels we talked about. It's a whole package designed to soak up or deflect radar energy.
Okay, and inside the cockpit, it sounds like they're aiming for information overload avoidance.
Definitely. The key seems to be this unified display. Imagine taking everything radar tracks, infrared signatures, electronic warfare warnings, data from the ground, from other planes, even from drone wingmen.
Wow.
And overlaying it all transparently in a single 3D picture of the battle space. The pilot sees everything relevant, hopefully without being overwhelmed. Makes for faster, better decisions.
You mentioned drone wingmen there. That seems to be a big part of the concept.
It really does. Manned-unmanned teaming, they call it. The pilot in the J36 or J50 wouldn't just be flying their own plane. They'd be potentially commanding a whole squadron of loyal wingman drones.
Using them for recon, electronic attack, maybe even taking shots.
Exactly. It multiplies the pilot's reach and options and keeps the manned, expensive assets safer. It's where air combat seems to be heading.
Okay, so we have these two incredibly advanced prototypes. Flying test beds, essentially. But getting from here to squadrons of operational fighters, that's a huge leap, right?
It's a massive challenge. Manufacturing these things at scale is incredibly difficult. You've got complex composite airframes that need to be perfect, applying those RAM coatings consistently, making sure they last.
Yeah, maintenance on stealth coatings can be tricky, can it?
Very. And just setting up the supply chains for all the specialized parts, the advanced electronics, it's a huge industrial undertaking.
But the sources suggest China is gearing up for that. They're making serious investments.
It certainly looks that way. Reports mention new tooling, things like robotic fiber placement machines for building composites accurately and quickly, dedicated software labs right there on site.
For continuous updates.
Right. And just a general sense of industrial mobilization. It doesn't look like they're building just a handful of demonstrators. It signals an intent for, well, potentially large-scale production.
And the timing. Showing these off now, it feels deliberate, especially considering U.S. programs like NGAD. What's the message?
Oh, the timing is almost certainly strategic. It's a clear signal. Look what we can do. We're catching up, maybe even pulling ahead in some areas. It's aimed at rivals, but also at allies and partners. Shows their growing capability.
How are neighbors and other major powers reacting? People must be paying close attention.
You bet. Countries like Japan, South Korea, They're definitely watching closely, probably reevaluating their own defense needs, their own future fighter plans. India, too, likely factoring this into their modernization.
And for the U.S.?
For U.S. planners, this confirms China as a peer or near-peer competitor in advanced aerospace. It definitely adds urgency to their own next-generation efforts and shapes thinking about how to maintain an edge.
So, as we kind of wrap up this deep dive, what are the main things we should take away about the J36 and J50? What's the big picture here?
I think the core idea is this shift towards seeing the aircraft not just as a machine, but as an integrated, almost a living system, as one source put it. It's the software, the sensors, the pilot, the network, all working as one.
So it's less about just speed or maneuverability in isolation.
Those still matter, of course. But the real differentiator, the future of air combat, seems to be this deep integration. How well can the whole system perceive, decide, and act? That's becoming the key metric.
Not just who has the most planes, but whose planes work smartest together.
Precisely. It's about that unity of technology and human skill. Outthinking and outmaneuvering the opponent through superior integration, not just overwhelming numbers or raw specs.
And this isn't the end of the story for these prototypes. There's more testing coming up.
Oh yeah, the next few years, 2025 to 2027, look crucial. They'll be pushing the flight envelope further, integrating weapons, testing electronic warfare suites properly.
And all that data feeds back into refining the designs.
Constantly. It's an iterative process. What they learn in these tests will shape the final production versions, the software updates, everything.
Looking at these designs, the J36, the J50, it really feels like a glimpse into the future of air power.
It really does. It's a significant step, no question. And it raises that big question, doesn't it? In this new era of incredibly complex, integrated aerial combat systems, who's going to lead and who's going to follow? Something for all of us to think about, considering the implications for security and technology worldwide.